In this tutorial, we will learn the concept of operator overloading for C++. We will do so through the creation of a simple matrix library. Now, as you see here, I've already gotten us started by creating the skeleton of our matrix library. We have a class with a public interface that has a default constructor, our destructor, and then a simple print function. Our private data consists of a multi-dimensional array called myData. Now, arrays in C++ are structured as shown up here, and what we're going to do is implement a few operators and then show that they work by using our knowledge of matrix algebra. So, first looking at our constructor, what I do here is I just loop over rows and columns and initialize everything to 0. Our destructor doesn't really do anything. We don't really have much to do. And then our print function just loops through our rows and columns. We loop through all of our columns, and so we'll print that out. Then we print out a new line character, and then finally we'll print out one final new line character at the end, and then we'll flush our standard out buffer. So the first operator that we're going to overload is just going to be the double parentheses operator. So that one looks like this, operator, and we're going to give it a couple of arguments. Now, first off, the syntax that we need to get used to is we declare everything with operator, the keyword operator, and then whichever operator we want to use. Now, it acts like a regular function, so we need to have a return type. In this case, we're going to return the address of a double. Now, we need to add the function interface. So, I want to add in int. I want to provide int row and int call as an input to this function. And it looks like we're going to have a matrix object matrix and then 1, 1. And that's what this function call is going to look like. The next one I want to do is the addition operator. So if I want to add two matrices, we want the result to also be a matrix, so we're going to return an instance of class matrix. Again, we use the operator syntax, or the keyword, and in this case we want to do an addition, so we'll just do a plus sign. We want the parameter input to this to be another matrix that will pass by reference on the right hand side, or as I'll abbreviate, RHS. And this looks like something like that. And let's also do the subtraction operator. This also looks like our addition operator. And let's also show what compound operators look like. So in this case, what if we want to do plus equals? And if that's the case, we're going to return a void, use our operator keyword, plus equals, and then we're going to have a reference to right hand side of the equation. We'll call RHS. Let's do M1 plus equals M2. And similarly, we'll do the minus equals operator. So this is the interface that we want to go ahead and implement. Now, the syntax here will look rather interesting, but when we actually go to use it, we can ignore the operator and we'll just call our functions like that. So jumping into the implementation, let's go ahead and implement our double parentheses operator. So again, we return the address to a double, and we're going to provide a row, or an integer row, and an integer called column. Now, the first thing we want to do is we want to double check the boundaries just for safe programming. So I'm going to do a simple if statement. If, and there's two conditions we want to look at. So if either one of these conditions fails, we want to do something. So let's look at what those conditions are. If we look at row, we know how arrays, if you try to index a negative element or you try to index past an element, you're going to get junk data. So let's guard ourselves against that by saying if our row is less than 0, or if our row is greater than 2, we're going to do something about it. And in this case, we want to throw an error, in our case, out of range. And the message we want to give is just error row index exceeds matrix dimensions. And this will kick us out if we reach that condition. Similarly, if we have the same thing with the columns, we want to throw another error. We'll print out another snarky error message if we do that. Our conditions are going to be the same. If our column is negative or greater than 2, because again we'll start 0, 1, and 2, we want to throw this error. If we pass both conditions, we're just going to return my data at row and column, and that'll be it. So if we want to implement the addition operator, we return a matrix, and the parameter input is going to be a matrix. So for this one, let's go ahead and declare our return matrix. And here we're going to set up 2 loops. We're going to loop over each row from row equals 0, row less than 3, and we'll increment rows. We also need to loop over our columns. Now our return matrix of at row and column, so we'll use the double parentheses operator we just created, equals my data, the calling function, at row call, plus right hand side, again we'll use our double parentheses operator at row call. So one thing to notice here is we never actually defined this assignment operator. That's one that's already defined in your compiler, and for our simple case, we don't actually need to define this assignment operator. Just know that it's already implicitly being defined. If you're doing funny things with pointers and storing the addresses of things, you'll want to define this operator so that you don't have any unintended consequences. So lastly, we'll return matrix. Now our subtraction operator is going to look just the same. So what I'll do is I'll copy and paste this, and I'll change this to be a minus, and then this to be a minus. And it'll be as simple as that. Now lastly, if we want to define our compound operators, we return a void matrix operator plus equals matrix right hand side, and then we'll set up the same for loops we had before. Now, because it's a compound operator, the calling matrix will be the one that has this data redefined. So we're going to have my data row call plus equals right hand side at row call. And it's as simple as that. Lastly, we'll do this with the subtraction compound operator. Now with that done, let's compile our program. Great, we didn't have any errors. So if you come over to our main or our unit test, let's create an object and we'll just call it matrix1. To test, let's do matrix1.print and see what happens. Because remember, from our constructor, we loop over everything and we expect it all to print out zeros. And there we go. So we're happy with that. Let's do, the first thing we want to do is test out our if statements on the double parentheses operator. So matrix1, -1, 0, and we'll do something as simple as that. So we see here, we created the object, we printed it out, and then we threw an out of range error saying row index exceeds matrix dimensions. So that did exactly what we wanted. Let's just double check the other side of it. We'll do 3. And then let's test it out. Row index exceeds matrix dimensions. So exactly what we wanted. Now what we can do is start filling our matrix. What I like to do is, for each index, I'll just use a decimal representation. So 0, 0 is equal to 0.0. Similarly, matrix 1 of 0, 1 will equal 0.1. Matrix 1 of 0, 2 will equal 0.2. And we'll run through the list like that. This will help us keep track of knowing that we put the right values in the right places. So now let's do matrix1.print and see where that gets us. So like we expected, we got 0.0 in element 00, 0.1 in element 01, 0.2 in element 02, 1.0 in 10. Uh-oh, we had an issue here. So let's change our value here, 1.1. So that's an easy way to check that we did this, that we either implemented the function correctly or put the right data in the right spot. Doing a quick pass over everything, looks like we got everything else right. So just to double check, now we have everything lining up correctly. 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. So that's what we expected. Now let's test out some of our other operators. Let's create another matrix called matrix2, and we'll do matrix1 plus matrix1. So we'll effectively double matrix1. And remember, we're going to trust the compiler's defined assignment operator. So what this looks like behind the scenes is essentially matrix 2 is equal to matrix 1 dot operator plus matrix 1. You can think of it like that. So now we'll print out matrix 2. Let's do a couple of other operations while we're here. So we've added it. Let's do matrix 2 is equal to matrix 2 minus matrix 1. So we should get matrix 1 again. And if we get that, let's do matrix 2 plus equals matrix 1. So just to keep ourselves straight, we'll call this original matrix 2. This will then have the same values as matrix 1. We'll have the same values as matrix 2 original. And we'll show that. So what we have here is our empty matrix. We have matrix 1. We then have matrix 1 plus matrix 1. So 2.2 plus 0.2 is equal to 0.4. 1.1 plus 1.1 is 2.2. 2 plus 2, 4, so on and so forth. We then subtracted matrix 1 from matrix 2 and obtained our original matrix. We then used the compound operator plus equals to obtain this new matrix, original matrix 2. And so lastly, if we wanted to do our compound subtraction operator, matrix 2 minus equals matrix 1, matrix 2 dot print and so we got what we expected, the same equivalent values as matrix 1. And so that's how you use define and use operator overloading in C++.